Today's lesson is section 5.4 in your workbook. It's also chapter 5, lesson 4 for us. And this is parallel lines and transversal. Last lesson we dealt with non-parallel lines, so when they do not run exactly the same to each other. And learning intentions for today are, first, to understand the relationship between angles made between two parallel lines and a transversal. When you have two parallel lines and a transversal, which is a line that cuts through them, there's some relationships there we need to understand. Number two, to be able to calculate the angles from parallel lines in a transversal. So if we know one of those angles between two parallel lines in a transversal, we can use that angle to solve some of the others. And last, to be able to prove lines are parallel based on information given by their angles. So if I know some of those angles values, then what I could do is I could tell you or prove that they are in fact parallel or not. Okay, so now what we're going to use is we're going to use some of the terms we learned last day with non-parallel lines. With parallel lines, the terms are still going to be the same. Corresponding angles, those were what we called F angles. Okay? And these were for backwards and upside down Fs. But what we know about them is when they are parallel lines, corresponding angles are equal. So if I have two parallel lines, let's say I'm telling you these are parallel, then these angles here, these F angles, are equal. If this angle here is 120 degrees, then this angle down here is 120 degrees. They need to be the same. They're equal. Next, alternate interior angles are equal to each other. Alternate interior was our Zs. They're interior because they're on the inside of our two lines, and they're alternate because they're on the alternate side or opposite sides of the transversal. So with these ones, here's our parallel lines. Mark them as parallel. Now, alternate interior angles are equal. So this angle in here and this angle in here, so we make our Z, they are equal. If you know the one is 60 degrees, then the other one has to be 60 degrees. Next, vertically opposite angles. These ones don't come out of parallel lines, but whenever you have two lines that make an X, the two opposite each other are equal. So if this one is 40, then this one here is 40. And the same can be said for these two. If the one on the left is 140, then the one on the right is 140, because they're vertically opposite to each other. They're making that X. Next, interior angles on the same side of the transversal are supplementary. These are our C's. So, interior angles, they're interior because they're inside of our parallel lines. On the same side of the transversal, notice our transversal that's cutting through, it's on the same side, they are supplementary. And supplementary is one of those terms you need to know. It means adds to 180. So if I have my two parallel lines, and I have a transversal, if I know one of them, let's say I know this one, then this other one down here, mark it with an X, these two are supplementary to each other, so they add to 180. So if I know the one of them is 100, the other has to be 80, because 180 is 180. And the last one, this is one you should have been working with, but I've put it in here because this is going to be used a little bit today. Angles on a line are supplementary. So if I have a line, and I have two angles, those two angles need to add to 180 degrees. If the one is 40, the other is 140. If I have three angles, okay, 1, 2, 3 angles coming out of that, if one of them is 80 and the other one is 40, angles on a line, because they're all coming out of this same spot, add to 180. So 80 and 40 is 120, leaves me with 60. Okay. So angles on a line add to 180. C angles add to 180. Vertically opposite are the same. Alternate interior, our Z's are the same. Corresponding, which are our F angles, are the same. Before we start looking at solving some of these things, let's do a quick review of the last lesson. You need to understand what is corresponding. So what would be corresponding? Let's write this down, I guess. What would be corresponding to angle 1? So corresponding are our F angles. So angle 1 corresponding to 1 would be 3, because here is our capital F. What would be alternate interior to angle 2? Well, alternate interior is our z's. So here's 2. Alternate interior, another way if you can't remember it's a z, alternate means opposite side transversal, so if it's alternate of 2, I know it has to be one of these ones. And interior means inside of the parallel lines. So inside of the parallel lines on opposite sides 2 and 7. So 7 would make our z with angle 2. Interior angle on the same side of our transversal. Our c's. Well, a c would be 1 and 2 would be c's. 7 and 6 would be c's to each other. Okay? So make sure that you're able to see all of these. And now next we'll use them. Now we're going to work on using some information here. So I have, whoa, I did not want to move that. I have 130 degrees. I have 70 degrees. And I'm going to tell you that these two lines are parallel. If you're not told they're parallel, you can't use these rules that alternate interior are the same. Only if they're parallel can you. And I'm telling you these two are parallel. So first, let's start answering some of these. And you can always answer them in order. That's the way the textbook sets up. In real life, it doesn't. You could just start solving any way you wish. And I guess you could if you see some other ones first. So what is angle 1? Well, first, look for the information you have. The only information I have here is that this is 70 degrees. So the hint is 70 degrees is going to help me find these other ones. So how does 1 relate to 70? Well, if I draw over top of it here, there is a z. So angle 1 is 70. Now angle 2. Angle 2, I can either find it's 70 two different ways. One, see this x? Vertically opposite makes this 70. And also, an upside down f, I'll just show it here, this one and this one. Okay, this one and this one, 70 and 70. They're corresponding. Now, to find angle 3, there's a couple ways I can find angle 3. Angle 3 is sharing a line with angle 2. And we know that when you share a line, the two angles that come out of it equal 180. So the line is 180, minus 70 leaves 110. I also could use our C rule. Here's my letter C. C, or also called interior, on the same side of the transversal, add to 180. Because I knew this was 70 already, 70 and 110 is 180. Now, on to the next side over here. Again, two parallel lines and a transversal. If this one is 130, well, there's a couple ways I can do it. One way, I guess, I know that this lines always add to 180. So 180 minus 130 is 50. Or I could have, maybe I didn't see that. I could have known this angle. Even though the question doesn't ask for it, I have a z here. So I would have known that's 130. Because z's, alternate interiors, are equal to each other. And once I knew that was 130, I know my c's. Here's my c. I know c's add to 180. So once I know this is 130, 180 minus 130 leaves me with 50. So there's a couple ways to find that one. And last, number 5. Again, 5 could be, I have an F right here. It's upside down and backwards. It looks like that right now. Okay, but it's this one here. F's are the same. So if this is 50, then that has to be 50. And notice, angles on a line always add to 180. Look, here's my line. These add to 180. So today's lesson, you're going to be using F's, Z's, C's, X's, angles on a line, all those to find out the measures of different angles. Another one you may end up having to use in the assignment is triangles. Let's say this is 40 and this is 80. Well, the thing about triangles is triangles always add to 180 degrees. So that would leave me with 60. A pretty poor looking picture because that doesn't look like 60 degrees. But they always need to add to 180. Another one, if you have a quadrilateral, a four-sided shape, the four angles have to add to 360. So if you know three of them, 360 minus 1, 2, 3 will leave you with your answer. Okay? So your job when you see parallel lines is look for F's, Z's, C's, and all these things to answer the important data. Next, what we'll do is we'll use data given to show if something is parallel or not. So a question might say, are line 1 and line 2 parallel? Well, to know if something's parallel, we can find their F's and their Z's, or their, sorry, we're not going to use X's. We're just going to use if their F's and their Z's. If the F's and the Z's are equal, they're parallel. If the C's add to 180, they're parallel. So here in this question, they've given us some information, but not an F, a Z, or a C. But we can use some of this other information here. So first of all, this data is not making much sense because this is nowhere close to 65 degrees. Let's say that is 115. That makes a little more sense. It's bigger than 90, obviously, so it couldn't be 65. So in general, you can use some visual sense to see if it makes sense or not. But to prove it and actually prove it, you have to use exact numbers. So let's try and see a C, an F, or a Z here. Well, if I know this is 115, I know that when I make an X, the vertically opposites, this has to be 115. Now, one of the rules I know are that if it's going to be parallel, if line 1 and line 2 are parallel, then this C, because this looks like a C, okay, it's backwards, but it's a C, I know that if these are parallel, then it has to add to 180. So 70 plus 115 equals 185. Those are not supplementary. So because they're not supplementary, these are not parallel. Okay? To prove they would be parallel, I would have needed this to be I'm struggling with the eraser here. I would have needed this to be 110. Because if this is 110, this is 110 because they're x's. And now my C is supplementary. 70 plus 110 is 180. So now I could say L1 and L2 are parallel. Okay? So that's it for today's lesson. You're looking for C's, F's, Z's, X's, points on a line to find the value of angles. After this, you should be done up to section 5.4 in your workbook, and then you're ready for the practice test. Good luck. Stay classy, math class.